I'm here to talk about Pearson's correlation. The Pearson correlation is just R equals the sum of the products of deviations over the sum of the squared deviations for x times the sum of the squared deviations for y square rooted. Your SP is just sigma xy minus sigma x times sigma y over n, and your SSX is sigma x squared minus sigma x squared over n. Your SSY is just sigma y squared minus sigma y squared over n. Now, the first thing that we'll want to do is find our SP. So here are the numbers that we're working with. And these are the numbers, and then I made rows for the numbers that I would need, the x and the y, the squared for each, and I added them up. Then I came over, and the 164 is from here, the 30 is from here, 36 is from here, and it comes out to 160, and then you follow your numbers through. It's 164 minus 1080 over 6, it's 164 minus 180, which equals negative 16. Your SSX comes out to 18, and your SSY comes out to 32. You just follow your numbers through. The 182 comes from here, 30 squared comes from here, which comes out to 900. Then you just plug your numbers in. Once you've got all three of these numbers, you just plug your numbers into this equation here. Negative 16 over the square root of SSX, which is 18, times SSY, which is 32. And you follow your numbers through, and it comes out to a negative 0.67. The negative tells you whether it's a positive correlation or a negative correlation. If it's a positive correlation, you'll have a positive number here. If it's a negative correlation, you have a negative number here. The number here tells you how good that correlation actually is, whether it's 100% correlation or 60% correlation, and then there is a chart that tells you whether or not it's critical. And you do that by finding the DF, of which is just n minus 2. It's 1, 2. And you go down one side, down the left side to find your DF, and across the top to find your 0.05. And you can find your critical area that way. And that's it. Have fun.